Hello everyone, this is Aparna Shetty from the Department of Computer Science and Engineering, AJ Institute of Engineering and Technology. So today's lecture I would like to discuss about exception handling, which is chapter 3 of module 3. So let us begin. First, let us understand the exception handling fundamentals. A Java exception is an object that describes an exceptional condition that has occurred in a piece of code. Okay, so some exceptional condition or some erroneous condition that occurs in a part of a code. Exception thrown by Java relate to fundamental errors that violate the rules of Java language or the constraints of the Java execution environment. So, when a programmer tries to violate the rules of the Java language, or if he tries to violate the constraints of the Java execution environment, an exception arises. Okay, that is, when he tries to violate either of these two, an object representing that exception arises. So basically this is the meaning of exception. When you are coding or when you are programming, okay, any of the statement tries to violate the rules of the Java language or the constraints of Java execution environment, the Java runtime system will raise an exception. Okay. So Java exception handling is managed through the use of 5 keywords. They are try, catch, throw, throws, and finally. Let us study each of these in detail now. First one, try catch block. We use try catch block for exception handling in our code. Try is the start of the block and catch is at the end of the try block to handle the exceptions. We can have multiple catch blocks with a try, and a try catch block can be nested also. Catch block requires a parameter that should be of type exception. So basically we will be handling exception by the use of try catch block. The statements where an exception can arise, such statements we will be putting it in the try block. Okay, and the statements that will handle the exception, those statements will be inside the catch block. Also, a catch block takes a parameter, okay, that should be of type exception. Also, a single try block can have multiple catch blocks, and also you can nest the try and catch blocks. You will have a clear picture about all this once we start with the examples. Next is finally. Finally block is optional and can be used only with the try catch block. Since exception halts the process of execution, we might have some resources open that will not get closed. So we can use finally block. So some task that you want to perform, even if an exception arises or an exception does not arise, you want to perform some task. Such task you will put it within the finally block. Okay. And one more thing that you have to remember, a finally block will only appear with the try and catch block. One example that they have given here is, suppose because when an exception arises, it halts the process of execution. So the program execution halts whenever an exception arises. In such cases, you may want to close the resources that have been opened for the program. Okay, such unwinding of resources or closing of resources, all these tasks you can perform inside the finally block. So the task that you want to perform, even if an exception arises or if it does not arises, you will put it in the finally block. This finally block is optional. Finally block gets executed always whether exception occurred or not. Next is the throw. We know that if any exception occurs, an exception object is getting created and then Java runtime starts processing to handle them. Okay, so whenever an exception occurs, an object representing that exception is created and Java runtime system immediately starts to handle that exception. Sometimes we might want to generate exception explicitly in our code. For example, in a user authentication program, we should throw exception to the client if the password is null. So whenever any exception occurs, the exception object will be automatically created by the Java runtime system. In some situations, we may want to explicitly generate exceptions in our code. Okay, one example of that is a user authentication program. We should throw exception to the client if the password is null. In such cases where we want to explicitly generate an exception, we need to use the throw keyword. Throw keyword is used to throw exception to the runtime to handle it. Okay, so manually if you want to generate exception and throw it, you can do it by using the throw keyword. Next keyword is throws. When we are throwing any exception in a method and not handling it, then we need to use throws keyword in method signature to let caller program know the exceptions that might be thrown by the method. Now suppose in any method we are going to throw an exception, but that particular method does not handle it. In that case, we need to use the throws keyword in the method signature, informing the caller program. Okay, the caller of this method, we need to inform, telling that the method is not handling the exception. So, in such cases, we need to use the throws keyword. The caller method might handle these exceptions or propagate it to its caller method using the throws keyword. So, using the throws keyword in a method, you are telling the caller method that this method will not handle the exceptions generated. So, the exception will be passed to the caller method. Either the caller method might handle these exceptions or propagate it to its caller method using the throws keyword. We can provide multiple exceptions in the throws clause, and it can be used with the main method also. Here the throws keyword is used in the method signature. So with this throws keyword, you can have multiple exceptions like input output exceptions, multiple exceptions you can have, divide by zero exception, divide by zero exception, array index out of bound exceptions. So you can have multiple exceptions along with this throws keyword. And also that throws keyword, you can use it with the main method also. Program statements that you want to monitor for exceptions are contained in the try block. So the statements where an exceptions may arise, okay, such a statement you will put it in the try block. If an exception occurs within the try block, it is thrown. Your code can catch this exception using catch and handle it. So the catch block is used to handle the exceptions that arises in the try block. System generated exceptions are automatically thrown by the Java runtime system. To manually throw an exception, use the keyword throw. So, by default, the exceptions are automatically thrown by the Java runtime system. If the user wants to manually or explicitly throw an exception, then he can do so by using the keyword throw. Any exception that is thrown out of a method must be specified as such by the throws clause. So, exceptions that are thrown out of a method must be specified by using the throws keyword in the method signature. So, this throws keyword you will use in the method signature whenever that particular method is not going to handle the exception. In that case, the exception will be passed to the caller method to handle it. Any code that absolutely must be executed before a method returns is put in a finally block. So, the code that you want to execute, whether an exception occurred in a method or whether an exception does not occur in a method, you want to execute certain statements. So, before the method returns, such statements should be executed. Such of the statements you will put it in a finally block. So, the finally block will always execute before the method returns, whether or not an exception has occurred. But this finally block is optional. Okay, it is left to the user whether he wants to write a finally block or not. This is the general form of exception handling block. First we have the try block, block of code to monitor for errors, catch block, catch, exception type 1, exception object, exception handler for exception type 1. Now this particular catch block will handle the exception of type 1. Okay, so it will handle the exceptions of type exception type 1. As we have already told that for a given try block you can have multiple catch blocks. So the second catch block over here will handle the exceptions of type 2. So this catch block handles exception of type exception type 2. Similarly, you can define any number of catch blocks to handle the exceptions. Finally, block of code to be executed before the try block ends. So, before the exception ends, okay, once the exception occurs and it is handled before the method returns or before the block of code to be executed before try block ends. Okay, such statements you have to put it in the finally block. This finally block will execute immediately after the try block. Okay, whether an exception occurred or whether it has not occurred, it will always execute. And this finally block is optional. It is left to the user to define the finally block or not. Next topic is exception types. All exception classes are subtypes of the java.lang.exception class. So, let us go through the exception class. On top of the hierarchy, we have the class throwable. This throwable class has two subclasses, error and exception. Exception subclass again has its own subclasses, that is input-output exception and runtime exception. So all the exceptions are the subclasses of throwable. Let us discuss each of these classes in detail. All exception types are subclasses of the built-in class throwable. Immediately below throwable are two subclasses that partition exception into two distinct branches. One branch is headed by exception. This class is used for exceptional conditions that user program that user programs should catch. There is an important subclass of exception called runtime exception. Exception of this type are automatically defined for the programs that you write and include things such as divide by zero and invalid array indexing. So, important subclass of the class exception is runtime exceptions. These exceptions are automatically defined for the programs that you write. Example of such exceptions are divide by zero and invalid array indexing. The other branch is stopped by error, which defines exceptions that are not expected to be caught under normal circumstances by your program. Here, below the throwable class, we had two subclasses, exception and errors. Now, exceptions, user program can handle them. But error class, user program is not expected to handle them because these errors are not caused due to programmer mistakes. These are caused due to system errors. So these errors are because of the system faults, not because of the user faults. So it will be handled by the system itself. These errors cannot be handled by the programmer or by the user. That is why they are telling they are not expected to be caught under normal circumstances by your program. Exception of the type error are used by the Java runtime system to indicate errors having to do with the runtime environment itself. So these are the errors that is related to the Java runtime environment itself. Example of such an error is Stack Overflow. Next topic is uncaught exceptions. Now, what if you do not handle exceptions in your program? If we do not handle exceptions in our program, the Java's runtime system will have a default handler for handling the exception. Let us see how it works. So we have a small program here which includes an expression that intentionally causes a divide by zero error. Let us see this class exec0, public static void main, string args, int d is equal to 0, int a is equal to 42 divided by d. Here we are trying to divide a number by 0. Whenever we are trying to divide a number by 0, an arithmetic exception will arise. Since we are not handling exception in this code, we have not defined the try block, catch block. We can handle exceptions in the code by defining the try block and catch block. In this program, we are not handling the exception. That is why the exception will be immediately taken care by the Java runtime system. When the Java runtime system detects the attempt to divide by 0, it constructs a new exception object and then throws this exception. This causes the execution of exec0 to stop, because once an exception has been thrown, it must be caught by an exception handler and dealt with immediately. So whenever an exception occurs in your program, the program execution halts immediately, because that exception which has occurred should first be handled. Only after that exception is handled, the program will continue its execution. So the execution of exec0 over here is stopped, because once an exception has been thrown, it must be caught by the exception handler and should be handled immediately. Over here, our exception handler is a default handler provided by the Java runtime system. In this example, we haven't supplied any exception handlers of our own, so the exception is caught by the default handler provided by the Java runtime system. Any exception that is not caught by your program will ultimately be processed by the default handler. The default handler displays a string describing the exception, prints a stack trace from the point at which the exception occurred, and terminates the program. Let us look how the output looks like. Here is the exception generated when this example is executed. So when you run the previous code, this is how the exception generated looks like. So the Java default handler will display a string representing the exception like java.lang.arithmetic exception : divide by 0 error. So this is the string that describes the exception, and in the second line over here, it is displaying the stack trace from the point at which the exception occurred, like at exec0.main exec0.java 4. Here the exception occurred in the main method of the class exec0, and also the file name where the exception occurred is exec0.java, and the exception has occurred in line number 4. So this is the stack trace describing where the exception has occurred. Notice how the class name exec0, the method name main, the file name exec0.java, and the line number 4 are all included in the simple stack trace. So this is an example of program not handling the exception. In that case, the exception is handled by the default handler, and the default handler will generate these statements. Okay, that is, it will display a statement describing a string representing that exception, and it will display the stack trace, okay, indicating where the exception occurred. Also notice that the exception type thrown is a subclass of exception called arithmetic exception, which more specifically describes what type of error happened. So the first line over there, okay, tells you what type of exception occurred. Okay, it is indicating that it was an arithmetic exception because you tried to divide by 0. Using the try and catch. Handling an exception manually provides two benefits. So handling exceptions manually in the program by using a try and catch block provides you these two benefits. Let us see them. First, it gives an opportunity for the programmer to fix an error. So it allows you to fix the error. Second, it prevents the program from automatically terminating. So we have seen that whenever an exception occurs, the program execution immediately stops. Okay, so such abnormal termination of the program is not something desirable. Correct? For every programmer, when he is trying to run the program, if the program execution halts, okay, it is not something that is desirable for anyone. So such automatic termination of the program you can avoid if you handle exceptions on your own in the program. Let us look at this example over here. Class exec2 public static void main string args int d comma a try d is equal to 0, a is equal to 42 divided by d, system.out.println, this will not be printed. Close the try block, catch block. Okay, this catch block has a parameter that is an exception object of type arithmetic exception. It is going to display an error message telling division by 0. Close the catch block. After that you have one print statement which will display after catch statement.